Hello and welcome to the Daily Space for Monday, July 23rd of 2018. I am your host, Dr. Andres Plazas, and as always, we're going to bring you a roundup of today's news from space and astronomy. So today we're going to talk about something that you may already know, which is we're going to have an eclipse soon. Let me center this and maybe center my face. There you go. That's better. So, we're gonna have the longest total lunar eclipse of the 21st century. This coming July 27. The totality of the eclipse will last about 1 hour and 43 minutes. And from start to finish, that is to say, from when the moon enters into the penumbra and then exits the penumbra of the Earth, it will take about 4 hours or so. Well, unfortunately, we people who are in North America won't be able to see it, but fortunately for those who are in Africa and the Middle East, even in Southern Asia or in the Indian Ocean region, will get a chance to appreciate the eclipse, even in some parts of South America as well. Not the total eclipse, but yeah. So just in case you guys you can follow up. If you're in North America, you can follow it up online. It will start, the time of the greatest eclipse, it will start at about 4:21 Eastern time on July 27th. And as I said, the total eclipse will last for about 4 hours, about 3 hours for 55 minutes. And well, then why is this eclipse so long in particular? In this particular case, if you think of, if we back up a little bit and you think of the umbra, which is the darkest shadow that the Earth produces due to the sun, you can think of it as a conical region, right? And sometimes the moon enters this conical region in the part that is narrower, close to the vertex, or enters in the part that is wider, like away from the exit. And in this particular um, occasion, then the moon is passing closer to the center of the cone or away from the vertex of the point of convergence of the cone. And is therefore going to take, it's going to be a little bit longer than an eclipse, than previous eclipses, such as the one that we had in the US, like in January. And just another point, why is this taking a little bit longer, is because the moon will be at a farther point from the Earth along its orbit. And that means that the moon will appear slightly smaller in the sky and it will take a little bit longer to go through the Earth's shadow. And an interesting fact is that, as you may know, the NASA has a probe called the Lunar Reconnaissance Orbiter, or the LRO, taking very cool pictures of the moon, very high resolution pictures of the moon. But it's a relatively older probe. It's been taking pictures for about 9 years or so. But during this eclipse, the components of the LRO will be turned off just to preserve the solar power battery from the solar power spacecraft battery and keep it safe during the most of the part of the eclipse. And some of you of course know this, but if you go to the CosmoQuest website, you can actually play a little bit around with the images taken by the Lunar Reconnaissance Orbiter and help us map the surface of the moon. And actually, this is one of the projects we've been working on lately with Dr. Matthew Richardson and others here at the CosmoQuest team. So if you guys have the chance, visit our website and go to Moon Mappers and look at NASA images and help us to get some science out of it. But okay, so that was the first story of the day. Just wanted to mention that out. And the next story that I want to comment about is about Mars. And the dust storms that have recently, like in the past few months, have been engulfing the Mars. So we have talked about this news in the past here in the daily space, but just to refresh our minds, so in June, one of these uh, storms that started to develop in Mars actually developed into a global scale storm. So here in the picture, you can see a picture of a comparison of a side of Mars before and after the storm. So what did this mean for the Opportunity rover? As you may know, there was a sudden drop in visibility, and this is a rover that uses solar power. So if you have a lot of dust, then it's gonna be very dense, very opaque, and then you're not gonna have a lot of solar energy. So the scientists had to suspend the activities to preserve the rover's batteries. And as of last week, as of July 18th, there was no response so far. But it's okay. We're optimistic that it will come back to life in the next few months. Um, because this storm could take even weeks or take even months for the dust to start settling. And okay, well, this happened to Opportunity, but that doesn't mean that we cannot still do science with this opportunity of that is presenting ourselves. So, what do we want to say? That there are other probes in Mars that actually are taking chance of this global storm to study it in more detail, because actually we don't know why this type of global storms happen. So, for example, we have the Mars Reconnaissance Orbiter, the MRO. We have the Odyssey, the Mars Odyssey. We have the Mars Atmosphere and Volatile Evolution probe, which is called MAVEN. And there's also another rover that is not powered by solar energy, but is powered by nuclear energy, and that's the Curiosity rover. So in these stories, we are going to learn a little bit about how each one of these missions is actually taking advantage of this storm to study it in more detail. So we start with the Mars Odyssey, for example. It has an instrument that is called the Thermal Emission Imaging System, or THEMIS. And then scientists using this instrument, they can track the surface temperature, the atmospheric temperature, and the amount of dust in the atmosphere. And allows the scientists to watch the dust storm grow, evolve, and then dissipate over time. One mystery that they're trying to solve is, as I mentioned before, how these dust storms go global. Because scientists they know that every Mars year is about 2 terrestrial years. During the dusty season, there are a lot of local or regional scale storms that cover one area of the planet, but scientists aren't still sure how these smaller storms sometimes develop and grow up, and they end up encircling the entire planet. So that's for the Mars Odyssey, but there's also the Mars Reconnaissance Orbiter, the MRO, and it has two instruments. It has several instruments, but in particular, two of them are studying the storm. So one of them is called MARSI, or a Mars Color Imager, that is mapping the entire planet in the mid-afternoon to track the evolution of the storm. And there's also another instrument called the Mars Climate Sounder, or MCS, that is measuring how the atmosphere's temperature changes with altitude. So using this data and this particular instrument, scientists want to study how the dust storm changes the planet's atmospheric temperatures. So it's similar to what happens here on the Earth. A change in temperature can affect the wind patterns and even their circulation over the entire atmosphere. This in turn provides feedback, right? And you have solar heating. You have the sun heating the dust that is in the atmosphere, that is going to change the temperatures of the atmosphere, which in turn changes the temperatures of the winds. And then this also could amplify the storm by lifting a little bit more dust from the surface. So, but scientists want to actually know the details of how this process is working. So, what is the Earth rising or falling, or how do the atmospheric temperatures now compare to a year where you don't have any storms? So yeah, so there's an example that is given is, as I said, scientists want to know why this particular type of storms arrive every few years, and an example that is given in the press communique is like if as if aliens were observing the Earth and then they see the climate effects of El Nino happen through many years, and then they start wondering why some regions get extra rainy and why some areas get extra dry. So in a pattern that seems to be regular. So we would like to understand, to have an understanding of the fundamental cause of this physical phenomenon on Mars. Then there's the MAVEN prof, the MAVEN, that is actually not studying the dust storm itself, but the team of of MAVEN actually wants to study how the dust storm affects the upper atmosphere of Mars, which is about 62 miles above the surface, where the dust doesn't even reach there. But they actually want to figure out what happened to the to Mars' early atmosphere. So in previous news, actually we know that at some point, maybe billions of years ago, there was liquid water that pooled and ran along the Mars's surface. This also means that its atmosphere must have been thicker and more insulated, like similar to what we have on here on the Earth. And since the arrival of this probe in Mars in 2014, the investigations have found that the atmosphere may have even been stripped away by a torrent of solar wind over several hundred millions of years. So you have the solar wind that is actually taking little by little away the atmosphere of Mars between about 3.5 and 4 billion years ago. But actually, there are still details, and we need to figure that we need to figure out. Like, for example, how dust storms like the current one affect how the atmospheric molecules escape into space. So the dust storm acts as an insulator, as an atmospheric insulator. So it traps the heat from the sun. So the scientists ask themselves, like, does this heating change the way molecules escape into the atmosphere? So so this is another type of questions that we can study with maybe not directly looking at the storm, but we can see how the storm affects other parts of the atmosphere, in this particular case, the upper atmosphere of the planet. And then finally, we have the rover Curiosity. Well, it is, as I said, is nuclear powered, and it's okay if there is no sun, because it doesn't matter, like unlike Opportunity. But they can actually still keep working, and they recently recommissioned a drill that is acquiring like rock samples. So scientists say that they're actually doing some sort of double duty, because they're still doing their actual science objective or mission, but at the same time they're trying to study what's going on with this storm. So in particular, it has different type of cameras or sensors. One of the is a chem-cam, a chemical cam, an ultraviolet sensor, and it has some other suite of weather instruments. So yeah, even when the drilling, also you can advance the dust storms, because as the um, as the drill starts to like create a hole into the surface of Mars, then you have to have these small piles of loose material that are occurring there, and then you can actually monitor the winds or what's going on, or to compare to other data when you didn't have any wind. So yeah, the basic idea is try to see how the changes conditions compare, and then try to take advantage of this. And while we unfortunately Opportunity is now hibernating because we cannot work anymore, this is still an opportunity or a chance that we have to study this particular phenomenon with other probes and instruments that we have on Mars. So we have to wait and see. No, scientists still think that the storm will last about a couple of months, as I said. So yeah, it's we should keep an eye on this and see how it evolves. And then there was a last story related to archaeastronomy. And this is a story that is talking about archaeastronomy in the northern part of Chile, in the Atacama Desert. And this is an investigation that focused on rows of cairn-like pillars. No, a cairn is like a mound of rough stones that are built like as a memorial or something like that. They're like basically these little like columns of stone. But these particular pillars, they're known in the Quechua language, the language of the Incas mainly, they're known as saiwas or markers. And you find these little columns like dotted throughout the desert, close to like an ancient pathway built by the Incas. The pathway is called the Capañan, which is an Inca road network stretching from the southern part of Colombia to the central part of Chile. So people actually have fewer ideas of what do these columns mean actually. And then, well, maybe you're guessing. Maybe they have some sort of astronomical relevance. So the lead researcher of this investigation, Dr. Cecilia Sangüesa, she's part of the Art Museum of Chile, the Pre-Columbian Art Museum of Chile, and she's been studying these saiwas for about 20 years. And they were not sure what the true purpose of these columns were, that they were built in the middle of the desert. They were saying these are too sporadic to be milestones, and actually they're not as useful as a science post. They're not that. So these researchers, Sangüesa, actually turned to the chronicles from the Spanish conquistadores from the 16th century. One of them, Poma de Ayala. And of course, when the conquistadores came, many of them actually wrote a lot of books about what they observed and what they saw. And sometimes this is the only source of information that we have from what was left from the pre-Columbian cultures. But then in this particular conquistador, and then suggested that this saiwas may have a calendrical or astronomical or even a religious purpose, of course. Um, Affiliated to the winter and the summer solstice. They were believing that the sun god, or Inti, the sun god for the Incas, was believed to rest atop of them. So Dr. Sangüesa actually approached astronomers from ALMA, from the Atacama Large Millimeter Array, and the European Southern Observatory. So then she found two astronomers there, Sergio Martin and Juan Cortés, that actually ran simulations on sunrises on selected dates. And then they found that the sun appeared to align perfectly with these markers. So of course, we think of it something akin to what you find in Stonehenge in the United Kingdom. But well, of course, Stonehenge is the most famous, but you find all these type of mounds aligned with cardinal points or with the solstices all around the British Isles, in Ireland and in all these places. So the very interesting thing is that, of course, that in the peoples of the Americas, that they were also aware, of course, of the night sky and the surrounding and the seasons, the changing of the seasons. Yeah, so then and one last interesting point related to this story is that an anthropologist, Jimena Cruz, actually, she's from Chile, and she works from an archaeological museum called Gustavo Page. Actually, she helped the historians and the astronomers to help to try to figure out what these things meant. So the astronomers from ALMA and from ESO, they made the simulations and they figured out that there was certain alignment with the solstices in the winter and in the solstices in the summer. But then you actually had to do experimental verification. So actually, this researcher Jimena, he actually went to the site And in the autumn equinox of 2017, well, I mentioned the solstice, but also the equinox is another important astronomical date, where you can notice the position of the sun. They actually waited for the sunrise, and they saw how they were actually aligning with the sun. So they figured it out. They figured it out that for the particular site that they visited, they saw that there was an alignment between two particular columns, but there was a third location that remained a mystery. And then the cool thing is that Jimena Cruz, as I said, she was a local, and then she remembered, like from a childhood family memory, that there were rituals observed in honor of the Mother Earth, of the Pachamama, the mother of space-time, or the Mother Earth in the ancient Incan cultures and the cultures of other cultures of the South America in the Andes. There was a ritual observed on August the 1st. So they actually suggested for them to observe on that date, and actually they found an alignment that corresponded to that particular and important date. So just backing up a little bit, so we know that this is not unique to this type of cultures. Now we know that the Western European ancient cultures have done a lot of. This is a fascinating topic, right? The cultures all around the world have done all these archaeological sites, have created all these archaeological sites. So we found this in North America, of course, and we found this, of course, in Egypt and very ancient civilizations. And it is very fascinating as well to try to figure out how also the other regions from South America, like the Incans, were also aware of the surrounding seasons, and it was also for political reasons, for religious reasons, also for practical reasons. Of course, it is good to know what when the seasons are going to happen, of course. Is good for agriculture. So yeah, I just thought that this was a very interesting story, and yeah, that's what I wanted to say today. Let's look at your comments, and yeah, thank you guys for paying attention. I'm gonna look at the comments right now. So hello Guido and Paranor001, Astro YYZ. Hello, Larry, Adam all together. Hi. Yeah, I think I don't have the exact. So people are asking about like the where if you're gonna be able to look at it in North America, and we're not gonna be able to look at it in North America. But actually, I don't have the map here with me, but you can easily find online. They usually tell you a map of where on Earth you're gonna be able to see this type of eclipse. And as I mentioned, it was gonna be mainly in parts of Asia or Africa. But if you want more details, like there are places like where you can see like this sinusoidal patterns, which is basically just the projection of the ellipse, sorry, of the orbit of the moon on the Earth, and you can see the different amount of times when you will be able to look at this phenomenon from different latitudes. So would this happen, Hannes Warfare, would this happen or any low gravity planet with a thin atmosphere or just ones without water? I don't remember exactly why this happened. Maybe the atmosphere, maybe you are referring to the atmosphere being stripped out of the planet. In this particular case, the researchers found that it was due to the solar activity. So I don't know if that's exactly what you're asking, but maybe you can ask me again and then we can try to figure it out. This is a question from Hannes Vorwerp. Sorry, I'm murdering the pronunciation of your avatar names. Okay. Do they have Netflix in space? I don't know. Probably not. It's a lot of internet bandwidth right there. I do know that this is a fun fact that some Russian astronauts during the International Space Station they were able to watch a game from the past World Cup. I think I don't know if a game or maybe just a part of a game. It's pretty um, hard to have high bandwidth internet in space. How deep is the dust on Mars? That question I don't know. I don't know the actual opacity for that. I do remember that in previous press releases they did have a picture, uh, like a graphic with several pictures talking about there was like a measurement of the opacity. Usually you measure it you try to estimate or you try to calculate the depth of a column of dust between the space and the observers. And I remember in previous press releases that they have like a picture of the surface of Mars under different types of opacities. So I don't know exactly how thick it is. They're saying that been saying that this is actually a very thick storm. I do know that the layer of dust that is falling on top of Opportunity is just about a few microns. No, it's not that the whole thing is gonna be on top of a pile of dust, but that's enough to to prevent it from getting solar energy. And yeah, the width of that layer of dust, as I said, is a few microns, which is comparable to the width of a human hair. Um, then I wonder when they send people to Mars, will they be able to send pictures to the crew? Yeah, that's a good question. Probably they will want to do something like that. If we're able to um, send pictures from other probes from Jupiter, and I mean, the problem is, of course, the bandwidth, and then to transmit all this data and in a timely manner, and you have limited resources, and that's gonna be a problem. But on the other hand, it's also gonna be in the interest not only because of the interest itself of looking at pictures, but also for the importance of the mission as well to be able to send these pictures. Astro YYZ. There are a lot of these built also by the indigenous Arctic people. They look a little bit different. That's interesting. I'm not surprised to know that, but I didn't know. So, but it would be interesting to figure out what they actually meant, or maybe see if there were any studies that point to what they actually meant. I mean, it's also interesting to see how the difference between different latitudes, because the farther you go to the north or to the south, the more pronounced are the seasons, of course. One thing that I've also found very interesting is that even in Colombia, in my home country, in the indigenous peoples, in the pre-Columbian people, you also find this type of archaeastronomical types, and they were able to determine the equinoxes and the solstice of June. But I think it's interesting because Colombia is so very close to the equator, so the latitude is not that big. It's a little bit in the northern hemisphere, but it's still uh, we don't have the four seasons as in the sense of, for example, in North America or Western Europe, or well, the places that are plus or minus 23 degrees on the Earth. And yet, yeah, these cultures in the equator were able to identify these moments where the sun, they were able to identify that there was something was going on in these particular dates, right? So, yeah. They should find someone Mars that will really get the speculation going. Yeah, that's true. We always speculate in starting with the canals on Mars, but in the end, we need to be skeptical, and as you know, um, first get evidence and then see what's going on. um, There are also Astro YYZ. There are also cairns for other purposes. Inushkuks built by the Inuit were built in a kind of human shape. Have been studying this at a university and it's complex. Yes, that's what I imagined. And I always find this fascinating, all these findings of archaeoastronomy, and see how having this cosmic vision actually in a way was important for our ancestors, right? Again, from practical purposes, but also for even more like for all the purposes of their life, like religious, politics, and this is a sense that I believe we should still keep nowadays, even now that we live in cities and we cannot see the sky, but it's good to be aware of the cosmos, and that's why actually what we do in this type of programs, and we try to figure out the cosmos together. People in the past were very good at finding patterns in the sky and then utilizing them for agricultural stuff. Yes, so a lot of they were trying to make sense of the world that they were observing in terms that they actually could comprehend, and yeah, as I said, it was in many cases it was a matter of survival to try to understand and the patterns of nature. Is it possible to post the link to the Chilean archaeastronomy story? Yes, I will do that. Actually, I saw that in the Guardian in English, and I did find the paper is in Spanish. The abstract is in English, but I'm gonna post it right now um, on the chat. That's the one from the Guardian, and then the paper itself that was written by one of the researchers that I mentioned. Oh, sorry. I can find it. Well, I think it's linked actually in the same in the article of the Guardian at the end. So yeah, I'll give me a second. Okay, I found it. There you go. Uh-huh. Okay. Is the dust storm caused by wind or is the dust being picked up electrostatically somehow? So yeah, I think I don't know what's causing the dust storm, and I think that a lot of these scientists are trying to figure out why we have dust storm on such a wide scale. So one of the things that they were suggesting it was feedback, like from thermodynamic feedback from the sun hitting the surface and then producing winds that it could turn like lift more dust. So that's one of the ideas that they had. That like one of the other probes that are on Mars are trying to figure out. Is there any talk of launching a spacecraft from Colombia or nearby equatorial countries? Um, yeah, well, it gets mm, a little bit political. So unfortunately, in countries such as Colombia, science is not a priority, which is something that you should not let happen in the U.S. But things are changing. So I see a lot of my colleagues talking about, for example, sending CubeSats or or partnering with other agencies to start doing something. It's not a priority for the government right now, but there are people guiding from the academia, trying even to build like a small space agency or to have something. I do know, for example, that well, we have Europe has the French Guyana, right? So that's French, that's France. So that's technically the European Union, and that's why the European Space Agency launches all this stuff they produce from French Guiana, which is right there in South America, but it's French, it's France. So yeah. Uh, Equatorial launch sites are nice, but latitude is not a deal breaker. Yeah, of course, we have been launching stuff from higher and lower latitudes. Unstable political infrastructure is, yes. So, yeah, things are getting better, and I do think that the space or astronomy is like a good driver for the development of a country. In the same way that astronomy has been a driver for science, back in the past, and history tells us. I do think that creating a space program, a civilian space program, is a good driver for the progress of a country. But let's see, maybe I'll someday I'll get to talk to the president of Colombia and tell him. So North Colombia is only 11 degrees north. The solstice sun only 11 degrees over the ecliptic. It's very hard. Yeah, that's like the northern part of Colombia, which is a desert. And the cultures that I was mentioning that I had in mind, they were actually even closer to the heart of the country, to the center of the country, the Andean regions, called the Muiscas. They were close to the Andean region of the capital of Colombia, Bogota, and the capital of Colombia has a latitude of even lower latitude at 4.5 degrees north. So, but still, you can drive a few hours from the city and find um, archaeological evidence that people have found correlated to astronomical observations, in particular the equinoxes and the solstices. Uh, okay. All right. Okay, everyone. Well, thank you. We had a very nice conversation. I hope you enjoyed it, and I will be actually here tomorrow again. Dr. Pamela Gay is traveling, and she actually has chosen to be part of the Hall of Fame of podcasting, which is awesome. She does an amazing job, and it is very well deserved. And she is traveling to receive that award. So I will be here tomorrow and on Wednesday. So thank you so much for watching, and this has been the Daily Space, a production of CosmoQuest, created by the Astronomical Society of the Pacific. Our goal is to put science in your brain, and if you like this show, please give us a follow. And if you want to sustain our efforts, please consider subscribing. Every bit also helps. And we'll be back tomorrow and every weekday at 1 p.m. Eastern Time in the United States, 10 a.m. Pacific, 6 p.m. London. Tune in tomorrow to see what is new in space and astronomy. Bye bye. Adios.